Projectile motion is something that you can see every day. Throwing a rock up high, tossing a basketball to the ring, dropping an object, and many more. Basketball? What's going on here? Why are we here? Looks like they're having some fun. But seriously, what are we doing here? Oh, maybe it's got to do something about, what's it called again? Motion? Something? I forgot. Oh, look, it's Janine. Maybe she knows something about this. I better ask her.
For today's episode, we're going to talk about projectile motion. Projectile motion can be demonstrated by just playing basketball. We're going to interview one of the players here. Come with me. Hey. Can you tell me what projectile motion is?
Projectile motion is the motion of an object or particle in which an object is thrown near the Earth's surface. It travels on a curved path under the action of gravity. Yeah, that's the projectile motion.
Can you give me a quick demonstration about what projectile motion is?
Hey guys, wait, let's show them how to demonstrate a projectile motion. Okay.
Did you see what the boys mean about projectile motion? Suppose that this ball was thrown with a 20 meters per second as initial velocity in a 5-meter distance. What is the height of the ball tossed? So in this diagram, we have our red line, which is the distance covered of 5 meters. We have our angle, which is 21 degrees, and our initial velocity of 20 meters per second. The green line shows our unknown. Do you still remember the acronym SOHCAHTOA? SO stands for sine equal to opposite over hypotenuse. Ka stands for cosine equal to adjacent over hypotenuse, and TOA stands for tangent equal to opposite over adjacent. In the given problem earlier, we need to find the height, and the height is the opposite since it is facing the angle it is across it. So to find the opposite, we're going to use SO, or sine equal to opposite over hypotenuse. Then we plug in the values that were given into the formula. Sine theta equal to opposite over hypotenuse. We first plug in the angle 21 degrees to sine. Since our opposite is the unknown, let's just name it x. Our hypotenuse has a value of 20, so sine 21 equal to x over 20. After plugging the values in, we cross multiply sine 21 and 20. It would then be x equal to sine 21 times 20. And then the final answer would be 7.17 meters. Our rock is thrown at an angle of 45 degrees off the ground. The initial velocity is 25 meters per second and the calculated height was 6 meters. What is the distance covered? So in this diagram, we have our 25 meters per second, our initial velocity in a red line, or red arrow, our angle of 45 degrees, and our height of 6 meters. Our unknown is the distance covered. In the second problem, our unknown is the adjacent side. So what we're going to use here is a ka, or the cosine equal to adjacent over hypotenuse. Just like the first problem, we first plug in the angle 45 degrees to cosine. Our unknown is the adjacent side, so let's name it x. Our hypotenuse has a value of 25, so cosine 45 equal to x over 25. After plugging these values in, we cross multiply cosine 45 and 25 just like the first problem. It would then be x equal to cosine 45 times 25. Then we multiply it and our final answer would be 17.68 meters. So now you know how to solve for projectile motion using trigonometry. Now let us have one last definition of projectile motion to end this episode. A projectile is an object upon which force acting is gravity. There are various examples of projectiles like I mentioned before. A projectile is any object that once projected or dropped continues in motion by its own inertia and is influenced only by the downward force of gravity.